The Progression of Succession, a study of Point Pleasant Park post-Hurricane Juan.
Hurricane Juan was an event that is sure to be remembered in Nova Scotian history. The tropical storm struck most of the eastern seaboard on September 29, 2003. CBC described the Category 2 hurricane as the worst since 1893. The combination of 151 km/h wind speed and intense rainfall left countless communities without power and with major damage. The hurricane also had devastating effects on the forests of Nova Scotia, including our local Point Pleasant Park. The hurricane was said to have uprooted 70% of the Point Pleasant's canopy, leaving the park patchy with vegetation and missing most of its large trees. What followed the hurricane is a process known as secondary succession, which is defined as the gradual change in an ecological community after disturbance that does not directly create a new substrate. This process is the major driving factor behind our research. It is important to mention that the Point Pleasant Park has an importance to everyone. The park is located on the ancestral land of Mi'kmaq, meaning it is rich in history and is well preserved. This is a major driving factor for our study, as researching and understanding the effects of the hurricane on the park may help us maintain the important ecosystem. Our overall goal was to examine the rate of secondary succession in the park since the hurricane. We wanted to compare the data of the park in the past 20 years about various variables, but most importantly 3 important ones. The first is looking at what the dominant species was back when the hurricane hit and comparing it to the current dominant species with ecological densities. The second is determining certain community metrics such as species richness and Shannon's diversity index to look at how these metrics trended over the past 20 years. The third is tree size and ecological density of the trees since the hurricane. To help understand our study, 3 research questions were developed to break down the aspects of the goal of the study. The first question asks us to look at the overall community of the park and how it changed over time since the hurricane. We are to also predict what will happen to the overall community as its recovery moves closer to being fully recovered. The second part of our study looks at the dominant species over years after the hurricane. Specifically, we want to see if the dominant species has changed since 2004 and compare the densities of the overall species. Finally, our research formulates around the chosen community metrics of species richness and Shannon's diversity index. Our goal is to investigate how these metrics change over the years since Hurricane Juan, and if these trends will continue once the forest moves towards its climax. Based on these research questions, we formulate 3 corresponding hypotheses. Based on our results, we hypothesize that the overall forest community at Point Pleasant Park has been annually recovering, and the density of species will continue to increase as the forest moves towards its climax. We also hypothesize that the dominant species in Point Pleasant Park has changed since 2004, with the original dominant species recovering but being overtaken by a new species that took full advantage of the effects of the hurricane. Finally, we expect to see that both chosen metrics of Shannon's index and species richness steadily increase in the years since the hurricane struck.
For the location, we chose 6 20-meter by 20-meter sites throughout Point Pleasant Park at the south end of the Halifax Peninsula. The area was chosen as it was hit hard by Hurricane Juan, and so it's a great place to observe the succession that took place. Some sites couldn't be measured every year, leaving us with only 4 or 5 data points instead of 6 in some years. In terms of tree diameter, it was measured at breast height, or 4.5 feet from the ground, and only plants with diameters of 2.5 centimeters or more were considered to be trees. The species of tree was also recorded. In terms of data analysis, we calculated total tree density, the density of the dominant tree species in 2004 and 2022, the red spruce and red maple respectively, species richness, Shannon biodiversity index, and Pielow's evenness. All calculations mentioned above were then plotted against the year in a scatter plot, and regression analysis was done since the data is quantitative rather than categorical. The regression analysis was done on RStudio. Figure 2 shows a map of Point Pleasant Park, marked with the sites and their numbers.
In order to look at the recovery rate of the overall community of Point Pleasant Park, we measured the total density of species each year since Hurricane Juan in 2003. Figure 1 displayed above shows the positive correlation between the total density of species and the year, and the R-squared value of 0.5281 displayed on the graph suggests a slightly moderate or slightly positive correlation as well. This is reflected as the trend line is positive but not steep at all, and could possibly indicate a large jump in density between certain years. However, there is no doubt the total density of species has increased since the hurricane. Our results from the graph line up with Turchin's theory of succession, which describes the metrics of a community such as density, diversity, and richness to increase after an event due to the abundance of new resources and space to grow. This also compares to Burley et al.'s findings that the hurricane can reset the succession in a park, but the ground vegetation can make a rapid recovery. This serves as a possible explanation to the moderate correlation, as the smaller ground vegetation could have recovered much faster and served as the bulk during the first couple of years of recovery, and the larger trees would catch up later, furthering the community's density. The results also support our hypothesis that the park community is recovering and will continue to do so until the park approaches the climax, as the trend line shows. However, this correlation could be inflated as it is possible for one species to make a very fast recovery and therefore make it seem as if most species are making a strong recovery when only one is. The data collected was also missing some years, which could also be an error source, as the correlation value is very close to being completely moderate, and the missing data could fluctuate that number.
These two graphs show the total tree density and the amount of red maples found in Point Pleasant Park from 2004 to 2022. There's a slight positive correlation in figure 3a, which shows the total density and time, since R value is 0.5281. Figure 3b shows the correlation between the red maple and time, where R value is 0.1886, which is also a slight positive correlation. As a comparison in Turkey, similar data was taken from 4 sites in Point Pleasant Park. They also had very similar observations to our data. In their research, the dominant species in 2006 were mainly the mayflower, grass, and wintergreen plants, and there was no presence of red maples. Then in 2015, similar to our data, the red maple significantly increased. As Point Pleasant Park was still in the early stages of succession in 2004, the dominant tree species was the red spruce. In 2022, the forest was in mid-succession, and the dominant species is now the red maple. The graphs show that the red maple had little to no density in 2004, meaning this may have not been a native species. If this is the case, Hurricane Juan was a window of opportunity for this species to take advantage of the newly available space and resources. If we were able to predict the future trends of the dominant species as the forest moves towards climax, we would need to look at the diversity, tree size, and evenness. Based on the previous data, we can see that all of these factors are increasing as the forest matures. Therefore, we can predict that each species will continue to increase until they reach carrying capacity. This is the stage where we will see more evenness in the diversity as the forest stabilizes. Sources of error can be misidentifying species, since students are collecting the data and most likely aren't familiar with the tree species. And also, not all sites collected data each year since 2004, meaning the data has missing gaps.
In order to document and measure the recovery of plant life in Point Pleasant Park after Hurricane Juan in 2003, we measured the diameter of the trees as well as the species of tree measured over multiple years between 2004 and 2022. Although there is a positive correlation between the Shannon Diversity Index and the amount of time passed since Hurricane Juan hit, the R value shown in Figure 5a, 0.3303, does not indicate a strong correlation. There is a weak correlation between biodiversity and time. Although species richness has increased, other factors may have changed less drastically, which led to a less steep correlation. It is shown in Figure 5b that the species richness had a strong positive correlation with the time passed since Hurricane Juan, as the R value was 0.6551, which is above the usual threshold for being strong, 0.6. The species richness has gone up over time, so there are more species in the area. This is likely due to the fact that there has been more time for the area to go through succession and there is more time for the plants to grow. She et al. Also saw an increase in species richness. Turchin says that flora cover peaked in 2009 and diversity may decline after the peak. Turchin also found a similar lack of biodiversity change to the one we saw. Although biodiversity and year only have a weak relationship, species richness did have a strong correlation with time, showing that more species were found, although the evenness may be unchanging. More species are being seen due to succession, but some species may be dominating the landscape, ensuring that the biodiversity index is not going up that much, not to mention how rare species are discounted in some biodiversity indices, but they are not discounted in species richness. Perhaps a few species were only found once. Not every year was measured in every site, and there could also be some inaccurate identifications of tree species because the identifiers were the students rather than any specific taxonomic experts.
Based on the data trends made after Hurricane Juan, predictions can be made on the succession stages of Point Pleasant Park. Succession stages are the gradual and predictable changes that are seen in plants over some time. Since data has been collected from 2004 until now, we can see these changes through diversity, tree density, and tree diameter at breast height, DBH. Between 2004 and 2006, a significant increase in tree density was seen, proving an early succession stage. In this stage, it is typical to see small, fast-growing tree species dominate in early stages, which is seen clearly in the average DBH of 2006. The Shannon Diversity Index was also observed to have increased. This suggests species diversity through Paley's evenness. It indicates uneven distribution. By 2010, the transition into the mid-succession stage can be observed through the increase in average DBH, diversity, and tree density. DBH is heavily linked to tree density. Therefore, as DBH and tree density increase, the forest matures. By 2015, we still see a mid-succession stage, but more developed mature trees with a mix of younger trees. From 2018 to present, a continuation of increasing tree density and average DBH is still seen. Since these trends are still seen in the data, a conclusion can be made that Point Pleasant Park is still in the mid-succession stage. Since Point Pleasant Park is an urban setting, there can be factors that affect the succession of the forest. Urbanization can play a big role in the succession if we compare it to a non-urbanized forest succession. Some effects are seed dispersal and the introduction of non-native species, which can change the succession rates. These normally wouldn't be seen in a natural setting. Another factor that can affect succession is the way humans maintain and manage the area. One obvious issue is the limited space that is given for growth. Since this is a public park, gravel paths must be maintained for easy access for visitors. This affects the succession since it eliminates space for growth. Many traditional teachings from the Mi'kmaq Nation can aid in the succession recovery of Point Pleasant Park. The Institute for Integrative Science and Health talks to Elder Albert Marshall about two-eyed seeing. This is where one can apply Indigenous and Western knowledge for the overall benefit of the two by using two different perspectives. This would allow us to be able to use Indigenous practices for the human involvement of guiding Point Pleasant Park to a mature forest again, while still using Western science that can emphasize other aspects which can reinforce the Indigenous practices.
Our research provides valuable insight to the overall understanding of succession in general forests. Many of the same principles, although affected by urbanization, can be applied to the natural forests that have experienced similar disturbances. For example, information about the composition of species and overall climate implications can be applied directly from our study to a natural forest, as these variables aren't or very minorly affected by urbanization. Also, the urbanization itself can be looked upon as an insight gained from the study as a tool to help prevent similar variables from affecting natural forests.
Regression analysis and R-squared are used to measure the strength of the relationships between variables. Our variables, tree density, the density of the dominant tree species in 2004 and 2022, species richness, Shannon Biodiversity Index, and Pielu's evenness, were all measured over time. Regression analysis is important to this study since it is a way to quantify the relationship between our variables and the time passed since Hurricane Juan. All of the variables depend on one another in a way since they are all being used to measure the attributes and health of the same ecosystem. The most connected variables, in my opinion, are species richness, Shannon Diversity Index, and Pielu's evenness, since diversity indices take both evenness and richness into account, as mentioned by Callahan and Nolan in 2006. All of these variables are always changing, and therefore they are all continuous and relate to each other in a continuous way.
There are no resources that give insight into the Mi'kmaq and Indigenous practices currently being used to guide the Nova Scotian governmental involvement in the forest and land management, so we came up with a few suggestions that can be encouraged. The first one is to not remove the fallen trees and plants. Removing the fallen trees is removing the way nature would naturally recover from this disturbance. The fallen trees and dead plants can be used as a nutrient source. Our second encouragement is to always be respectful of the surrounding environment. This can be done in many ways. A good way is to respect the park is to stay on the trails provided. This might not be as encouraged in the Mi'kmaq Nation, but in my nation, this is heavily encouraged since it is a sign of respect to make as few disruptions as possible. This would also connect to the second way of showing respect. Don't damage or step on plants. The last way we can show respect is through not leaving anything behind that isn't supposed to be there. A good example is to not litter.